Hello class, this is teacher Meta. How are you? I hope you all feeling fine. As for me, I'm feeling great. My spirit is very high. I'm very happy today, and I hope the lesson will be a happy one too. And today's lesson is about the effects of the types of electrodes on the products of electrolysis and predicting the products of aqueous solution. These two important subjects, which is a continuation of the previous lesson on electrolysis of molten compound and the electrolysis of an aqueous solution. I'm pretty sure you are well versed with those lessons, and this week we will carry on with the types of electrode used in electrolysis, where different products are being produced. At the same time, we will learn how to predict the products of an aqueous solution. And before we proceed on to that lesson proper, I'd like to bring you back to last week's lesson, where we were discussing, or where we discussed about the ion symbols. Remember? So it was a slip of the tongue that it was mentioned earlier that the anions having all these negative charges, like the fluoride ions having F1 negative, the chloride ions Cl negative, and the oxide ions O2 negative, and the nitride ions as N3 negative. So these all symbols to show the charges of that particular ion. And these charges can be confusing when you write the equation, or to understand the electrolysis, the process of electrolysis, who is giving off electrons and who is receiving electrons. So how do you know which ions give off electrons and which ion receive electrons? So this is the symbol that will determine which ion gives off electrons and which ions receive electrons. So if you recall, I've shown you the oxygen atom having 8 protons and 8 electrons. So in this situation, they are stable because that is their original form. But you know, the nature of the atomic world, always wanting to acquire a certain standard of status, like the octet status, having 8 valence electron, full valence electron on the outermost shell, just like lithium, you know, having 3 electron, 1 extra than helium. So wanting to attain the duplet status, will shut off its electron and make the outer shell disappear, and it appears just like helium, having only 1 shell with 2 electrons, but then haven't get rid of the proton, rendering it, you know, having 1 extra proton. So for all the cations with a plus symbol, it only shows that they have extra protons. It's either 1 extra, 2 extra, or 3 extra protons. Whereas on the anion, what having these negative charges is the opposite. Meaning, if oxygen, atom with 8 protons and 8 electrons, and having 6 on the outside shell, the valence electron. They want to have a full set of electron on the outermost shell. Will do something to other atoms to get off or to get their electrons. So now oxygen have achieved its goal of getting 2 more electrons to make a complete shell of with 8 electrons. So well, it achieved its octet status, but did oxygen really become a noble gas, sort of? No. Oxygen instead become an ion. So when you look at the symbol here, it's written as O2 negative. What does it mean is it has 2 proton less than the electrons they have. So oxygens, all the oxygen, they're typically given as O2 negative, because they are very active and they like to grab electrons from other elements. So that's the reason why they always have 2 extra electrons, but instead have 2 at the same time having 2 protons less. So instead of having 10 protons and 10 electrons, now oxygen only have 8 protons and 10 electrons. So the negative sign means that oxygen has 2 less proton. So 2 negative means 2 less proton. Just like fluorine, or what a single negative charge, like chlorine, also with 1 negative charge. It simply means that they have 1 proton less. Like nitrogen having 3 negative, so nitrogen ion have 3 protons less. So that is what it really means. So 2 means less 2 protons. 3 negative means less 3 protons, and negative simply means less 1 proton. So either you see as negative, 1 negative means 1 proton less, 2 negative means 2 proton less, 3 negative means 3 proton less. Although you can also see as negative 3 means 3 extra electrons, or negative 2 as 2 extra electrons, and negative 1 as 1 extra electron. But to look at negative sign and then having to add, it doesn't make sense to many people, because whenever we see a negative sign, it shows a symbol of having less. Then how come now with negative it is more? So that's the reason I prefer to look at this, all the negative signs, as a symbol of having less protons rather than more electrons. So by convincing myself that negative symbol simply means less proton, it make my work easier when I do equation, or when I want to draw an electrolysis of substance. So I will know which one gives electron and which ion receive electrons. Because if you see an ion with a plus sign, plus symbol, like lithium, so when you know that lithium have Li plus, 1 plus, meaning it has one extra proton, so definitely it is having less electron. So when it has less electron, all the cations will definitely receive electrons in order to be stable. So here when it is a negative sign, so meaning they have less a proton, meaning they have extra electron. In order for them to be neutralized, they have to give off electrons. So always remember, cations, all the plus ions will receive electrons in order to be discharged, whereas the anions will give off electrons in order to be discharged and be neutral again, and be themselves, be the atom they were before. So that is what these negative signs mean. Because it is very important when you write your equation. So that is another issue that we like to discuss today, writing of half an overall equation. We take for granted when we look at all the equation written and we try to remember everything, but there is not much to remember, except that you have to know how to count all the ions involved and what are the product it produces. So as an example, we look at example 1. At the anode, this is how it is written. Remember, at the anode. So when you look at this half equation, it's written as 2Cl negative, and that is written as AQ in bracket. So this simply means 2 chloride ions in aqueous solution will react and yield a molecule of chlorine gas, that is Cl2, when it gives off its electron. You see, when you look at 2Cl negative, there is a plus sign there after the product Cl2 gets plus 2 electron. So this is where the confusion is. Either you are saying that this chlorine gas is achieved or it's formed by giving 2 electrons. So this is not what it really means, right? So what it means is 2Cl negative, meaning we are talking about 2 chlorine ion, 2 chloride, each having a negative charge. As I said, for them to be normal, if you see that they have a negative charge, meaning they have 2 extra protons. So when they have 1 extra proton, 1 less proton rather, because they have extra electrons, So when they have 1 extra proton or 1 extra electron or 1 less proton, so for them to be neutral, they have to give off the extra electron in order to balance up. So that's the reason now 2 chloride ions have to give up its electron in order to become chlorine gas. So the moment 1 chlorine give off its electron, it will become a chlorine atom, and another chloride gives off its electron, that ion also become an atom. So 2 atoms of chlorine will form together, bind together or bond together to be chlorine molecule, a gas molecule. So here you will always see that the electron is written last as compared to example 2 at the cathode. At the cathode, you will see that this ion, copper 2 plus or copper 2 positive, aqueous, plus 2 electrons will yield copper metal in solid form. So here you look at these two equations, you will see that at the anode, electron is written last, whereas at the cathode, the electron is written before the product, whereas at the anode is written after the product, last after the product. Now this you have to be very concerned, and you have to be very sure, and you have to be conscious, so that when you write, you will write correctly, especially at the anode. Remember, at the anode, the electron must be written last, whereas at the cathode, the electron is written before the production of the product. Always remember that electrons are written last after product for the anode, and electron written before product for at the cathode. So if you can remember this, you don't have to, you will not do any unnecessary mistakes. And of course, you have to write the in the formula, the half formula, whether it is aqueous or is a gas, whatever that is involved. So if the ion is in aqueous, so you have to write in aqueous. If the ion is a liquid, you have to write in liquid. And if the product is a gas, you have to write gas, G. If it's solid, you have to write S, as the symbol have shown. And look at this equation. Then for the overall equation, all you have to do is you combine both the 2Cl and the 2Cus. So when you combine the 2Cl and 2Cus, what do you get? Then you get the overall equation. But when you write, you will not write 2Cl first. You have to write 2CuCl, meaning you have to use the hypothesis first, but then there is no such thing as chloride copper. What we have is copper chloride, so we have to use 2 copper chloride in aqueous, will yield 2 copper atom solid plus chlorine gas molecule Cl2. So in this overall equation, there is no need to write all the electrons. The electrons are only written at the half equation level. On the overall equation, you just write what are the component, what are the elements involved, and what is the result, the product, the reactant and the product. So what is the reactant here? 2Cl, 2CuCl is the reactant, and what is the product? You have 2 copper and 1 chlorine molecule. So as you can see, Cl2 means 2 chlorine molecule, 2 chlorine, it comes from 2 chlorine ions, and the copper comes from 2 copper ions. So 2CuCl as the reactant will produce the product, 2 copper atom in solid, and a chlorine gas molecule. So that is how you will write, and I hope you will remember this and practicing. You have to practicing writing in order for you to get used to writing this equation, because there will be a subject on balance of equation later, and that is where so many formulas need to be written, and you have to write it correctly. Okay, so on our lesson today, we will concentrate on types of the effects of types of electrodes on the products of electrolysis. You know, the effects of the types of electrode used in electrolysis, and what kind of product you get out of it. So in this particular example, we are using copper electrode for both the anode and the cathode. So what will happen to the process of electrolysis when you use an electrode which is not inert? Electrodes which are not inert will involve themselves in the electrolysis itself, unlike carbon. So what happens when you use copper electrodes as the anode and the cathode? So the solution is a dilute form of copper sulfate solution that is only about 0.1 mole per cubic decimeter. It's just a small amount. So what happens when an electric current is run through the electrodes in this electrolysis? So one thing is for sure, when different types of electrodes, copper and carbon, are used in the electrolysis of copper to sulfate solution, products formed at the electrodes are different. Now that is the hypothesis. So can we prove that? So let's see what happens when we run through an electric current through the electrodes. At the anode, the copper electrode, not being inert, is ionized by losing electrons to form copper 2 ions. Now the electrode is forming copper 2 ions, and of course it will lose mass, and the sulfate ions and the hydroxide ions are not discharged at all. At the anode, this is what will happen. So what happens when the copper electrode, the anode, get ionized and loses its mass? This is what happens. The copper electrode dissolves in the electrolyte and becomes thinner, whereas the copper cathode becomes thicker, because the ions will travel to the cathode and stick to the cathode, and as a result the cathode becomes thicker, and the anode becomes thinner. Sometimes it will disappear totally. So the Hub's equation shows that copper atom in solid form, the electrode itself, will react and ionize and produce copper 2 ions in aqueous form when it releases its 2 electrons. So they happily release its 2 electrons, then they form ions, and then once they are in ion form, they start moving freely in the solution and get attracted to the cathode. As you know, cation with plus charges will always get attracted to the cathode, which has a negative charge. So they will bind and stick themselves at the cathode, and the result is the cathode becomes thicker. So copper 2 ions are formed, and the anode becomes thinner. So this is what happens when you use non-inert electrodes. They get involved. When they get involved, this is what happens. Right? Now this is useful because in industries they will use this similar way of extracting metals to purify metals. So we'll learn that later. But then this example is showing what happens at the cathode. Just now we know what is the result of the at the anode. So there's the same copper electrodes. Now copper 2 ions are selectively discharged at the cathode itself. Although they are made of same stuff, that is copper, the cathode is also copper, but then it will not get itself discharged by gaining electrons, but other ions that has been attached to the cathode will now receive electrons and get themselves discharged. So that is the result again. When the ions, the copper 2 ions travel to the cathode and they get discharged, they are growing and making the cathode thicker and thicker. Right? So here you can see the ions, copper 2 ions, when they give off, when they receive 2 electrons, so they form into copper metal. Earlier at the anode, copper metal is being ionized and discharged as or move freely as copper ions, from copper solid to copper ions, and here again the copper ions are being reformed back into copper metal. This is the reverse. So even one more fact that you need to remember: when the transfer of these ions from the same type of copper electrodes will not change the color of the solution. The intensity of the blue color of the solution remain unchanged because the concentration of copper 2 ions remain the same. The rate copper 2 ions produced at the anode is the same as discharge at the cathode. They're doing the same thing at the same time. One get oxidized and the other got reduced. So oxidized and reduced. So the anode get oxidized and the cathode get reduced. So that's the reason when you look at a nail, a rusty nail, it appears like the cathode. So we say, the nail is oxidized. So by giving off its electrons, it will change form into ions, and eventually they will disappear, just like a rusty nail will just disappear. But when they disappear, they just don't disappear into thin air, but they will disappear and get attached to some other element. That element will get reduced. So here you can see the effects of the oxidation of the anode and the reduction of the cathode. So you call it reduction, but actually they are getting bigger and bigger, right? Sometimes in chemistry, that's what it is. When you iodize, you oxidize, you get thinner. When you reduce, you get bigger. Anyway, that's for you to figure. Now for the same amount, but this time for the same amount of copper 2 sulfate solution, and using copper electrons instead. So let's see what happens. As usual, at the cathode, copper 2 ions will be selectively discharged because of the position of the ion, which is lower than hydrogen ions in the electrochemical series. So naturally, copper 2 ions will gain the electrons and more readily form copper ions, copper atoms. So as you can see here, the cathode is coated with a layer of copper metal and becomes thicker. The copper 2 ions in aqueous, after receiving 2 electrons, will turn into copper metal in solid form. But what happens at the anode? Now this is another issue. So the cathode is already coated with a layer of copper metals and becomes thicker. But what happens at the anode? At the anode, the hydroxide ions are selectively discharged because they are lower than sulfur ions in the electrochemical series. So all these OH negative, they will get discharged. So hydroxide ion release electrons more readily to form water and oxygen molecules. So that's what will happen. So they will produce 2 water molecule and an oxygen gas molecule. So oxygen gas is given off and water is produced. So the half equation here is written as 4OH negative aqueous as the reactant will yield 2 H2O molecules, 2 water molecules plus an oxygen molecule, O2 gas, after releasing the 4 electrons. So you have seen the difference at the cathode and the anode. Although we use the same amount of materials in the solution, but because we use different electrodes, different types of electrodes. When we use carbon electrodes, this is what will happen. This is the product that we will receive from the same substance that we electrolyze. But when we use copper electrode, we have different product. We only have one particular product, and nothing is given off at the anode, but everything has been transferred from the anode to the cathode. So I hope you can see the difference when you use different types of electrodes on the electrolysis and what are the products they receive. So now it's time for you to predict. How are you going to predict products of aqueous solution? I'm sure you have gone through your studies, and you have to force yourself to start predicting what is the result from the reactant, what will result. As example, if we use 0.001 mole per cubic decimeter of aqueous copper 2 chloride, and here we use carbon electrodes, using carbon electrodes. Now what will you get from this? So the formula or the equation is CuCl2 aqueous as the reactant will produce Cu2 aqueous plus 2Cl negative. And these are the ion. They produce the ions, and H2O, they will get themselves ionized and release the hydrogen ion and the hydroxide ions. So these are the four ions being produced from this copper 2 chloride solution. So how are you going to predict the product of this ionization or electrolysis of this solution? And number two, look at the difference. This time is 2.0 mole per decimeter, per cubic decimeter. Just now number one is 0.01 mole. Here is number two is 2.0 mole. So there's a lot of difference, you know. So the concentration is very much higher. Number one is very dilute, when number two is more concentrated. So number two, we're talking about 2.0 mole of per cubic decimeter copper 2 chloride, also using carbon electrodes. So what are the product that you can derive from this? So the equation shows that CuCl2 or copper chloride in aqueous will produce copper 2 ions in aqueous and 2 chloride ions also in aqueous. When H2O in liquid will ionize and produce hydrogen ion in aqueous and OH negative in aqueous. Now you have to write this down and do your own electrolysis and predict what is the product you can derive from these two electrolysis. Alright? So here we are showing you the factor affecting electrolysis. So what is the factor that affect the electrolysis? One, if you remember, is the position of the ion itself in the electrochemical series. B, the ion concentration, and C, the types of electrode. So we have shown you all three. So now for 0.01 mole per cubic decimeter of dilute copper 2 chloride solution, you know, what will happen at the anode? So what will you get from the anode when electricity is run through? So you will find that you will have chlorine, chloride ions and hydroxide ions will get attracted to the anode. So now they are gathered there. So which one of them will get selectively discharged? Will it be chlorine ion or will it be hydroxide ions? Which one do you think? Chlorine? Are you sure? No, the situation is OH is very much lower. OH negative position is very much lower than chlorine, right? So OH ions will be discharged because the position of OH ions is lower than chlorine ions in the electrochemical series. So now you look at this. For any solution that is in dilute form, then the position of the ions in the electrochemical series will take hold. So in this case, the hydroxide ion will be discharged. So what happens? Bubbles of colorless gas produced, that is the oxygen gas, which lights up a glowing wooden spoon. To test that, you just put a glowing wooden spoon and see whether it glows or it pops. So if it pops, means it is hydrogen, but when it glows, meaning it is oxygen. So then you can see from this equation, 4OH in these 4OH ions in an aqueous, solution will yield 2 water molecule 2H2O in liquid plus an oxygen gas molecule, so get released off. So at the anode, the moment they give off the electron, this is what will happen. So when the electrons are sucked out from the ions, then they will get discharged, and instead of chlorine, hydroxide will be discharged. So an oxygen molecule is released and two water molecule is produced. For this, if the concentration of ions is very minute, it is actually a dilute form of copper 2 chloride. So what happened now when we use concentrated copper 2 chloride solution of 2.0 mole per cubic decimeter? This is a lot more. So now we have the same ion, this is the chlorine, chloride and the hydroxide. So which one will get discharged? Which one will be selectively discharged? I think you can guess it right by now, right? So obviously this time chlorine will get discharged because the concentration is very much higher. So when the concentration is very much higher, it will override the position of ions in the electrochemical series. So chlorine, the chloride ions are discharged because the Cl chloride ions concentration is higher than the OH ion, the hydroxide ions. So what happened then? So two chloride ions, will will form chlorine gas when two electrons are being given off by the two chlorine ions. So when two chlorine ions give off two of the electrons, back to the anode, so they get themselves discharged into chlorine atom, and two chlorine atom will bond together and become chlorine gas and release. So bubbles of pungent yellowish greenish gas are produced. That is the chlorine gas. And when you test the litmus paper, from blue will turn to red. So that is the result of the electrolysis. Now at the cathode, different things happen. Just now we are talking about the anode. So different concentration of solution will react differently at the anode. But as far as the cathode is concerned, whatever concentration, either is dilute form or concentrated form, still something different happen. So here we have these copper 2 ions and the hydroxide ions. Which one will get selectively discharged? Here without fail, it should be the copper 2. Simply because copper 2 is situated lower than hydrogen in the electrochemical series. Therefore, copper 2 will get a discharge. And below copper, do you remember what is below copper even? You have silver, and below silver you have gold, and below gold you have platinum. So at the cathode, is where you will place whatever things you need to do the electroplating. Because if you want to have the the silver spoon, just hang a silver spoon as a cathode, so you'll get silver coated onto the spoon, so you get a silver spoon. So here what we'll see is we will get the copper 2 be discharged. So the copper 2 ions are discharged because copper 2 is lower than H plus ions in the chemical series. See what happened? So copper 2 ions in aqueous after receiving 2 electrons will produce copper metal in solid form. So this is how you can predict products in an aqueous solution. 3 important factors you must always remember. Number 1 is the electrochemical series, the position of ion there, and number 2, of course, the concentration of the substance used, and the third one is the type of electrodes used. So always remember these 3 factors when you want to do your prediction on any aqueous solution, because it involves more than 2 ions at the same time. I hope this lesson explains enough for you to do your next lesson. So next week we will be discussing about the electrolysis in industries. So how the industries do gold plating, platinum plating, or silver plating, or whatever plating, right? So until then, this is Teacher Madda saying farewell, have a nice day, and thank you for your time.